Okay, quick review of these RTD problems, coin problems, mixture word problems for your final review. So you have the information here about Johnny and his dad. Basically, this is just saying that Johnny takes off at 8 miles an hour. 5 hours later, his dad tries to catch him, and it takes him an hour to catch him, and he wants to know the rate of the father, what he was traveling. So I have this set up for you in a table. Johnny was traveling 8, his dad was X, because we don't know that. Now, where these times are coming from is that it says that Johnny took off and rode for 5 hours. Well, you would think that that's 5, but his dad actually caught him an hour after he took off. So Johnny rode for 5 hours, Dad then drove for an hour, so together that makes Johnny's total time 6 hours. So his distance is 8 times 6 is 48. Now again, Dad's rate is X, he traveled for 1, so 1 times X is X. Now looking at this diagram here, if Johnny's distance was 48 and X is this distance, and when he catches him the distance is the same, obviously his distance is 48. X is equal to 48, so his rate must be 48 miles per hour. Okay? Let's go take a look at number 49. It's another RTD problem. So this time we have two trains starting from the same time in the same town. One travels at 85 miles an hour, the other at 51 miles per hour. Those are the rates. And we want to know how long it's going to take them to be 153 miles apart. Okay, the key here is knowing that they're going the same direction. And I didn't specify that in the problem, but hopefully you'll recognize that. And any question on the final will be very specific if that they're traveling, which direction they're traveling. So let me take a look at the chart that I have set up for you here. So you got a slow train at 51, a fast train at 85. It wants to know how long one is going to be certain distance, 153 miles ahead of the other. So the time is the unknown value here. So again, R times T equals D, so that times that is his distance, and that times that is his distance. And I've drawn a little diagram here. They take off from the same place. This guy's just chugging along at a rate of 51 miles an hour for X amount of hours. This guy's going way faster at 85 miles an hour for X hours. And then eventually he's going to have a gap, a lead of 153 miles on him. So if you look at this, you can do actually 3 different equations that are really the same. It's the slow one, which is this, plus 153 miles should equal the fast one. Another way of saying is the fast one minus 153 miles is equal to the slow one. And finally, the way I have it is if you take the fast guy's distance and subtract the slows, you should equal 153. And the reason I like that is because these are just like terms. So 85 minus 51 is 34. And if you divide both sides by 34, 34 goes into 153 4.5 times. So X means you have traveled for 4.5 hours before that distance. Number 50 is a mixture problem. So the key is just to know that pure copper means it's 100% copper, and you're going to mix it with 10% to get something that's in between, just like we've talked about all year long. You have strong stuff mixed with weak stuff to get something in between. And it says how much pure copper. That means that this is your unknown. How much pure means the X is going to apply to the 100% stuff. And they're giving us a quantity here of 36 kilograms of the new mixture. So let me show you what that looks like. Okay, APT, amount times the percent equals the total. So pure, that's the 100% stuff. How much pure means we're going to have an amount of X. The percent is 100, which is a decimal of 1.00. You multiply those together, you get 1.00X. The 10% stuff is the mixed stuff we're mixing with. This is the weak stuff. And don't worry about this amount column for now. Just fill in the percents. 10%, remember, is 0.1. And this times this is going to get you this, and I'm going to tell you where this came from in a minute. But the 25% stuff is they told you that this is the amount, 36. Well, if I tell you the total is 36, and let's make up a number here. Let's say that this was 10. This is the total amount. If this is 36 and this was 10, wouldn't this have to be 36 minus 10 or 26? So when I give you the total amount, one of them is going to be X, the other is going to be the total minus X. And then again, this column just comes from multiplying across here, and I distribute this to get this, okay? Now you could have decimal busted right away here and made that 100 and that 10 and that 25. Just know that then you're converting percents into percents rather than just decimals, okay? So then you have your equation here, and 1.00x is 100x plus 3.6 minus 10.10x equals 9. Now again, you can decimal bust. You can move the decimal over twice for everything and you would be okay, or you could just leave it like this. If you combine like terms here, 100% minus 10% is 90%, or 0.9. Minus plus 3.6 is 9. Subtract 3.6 from both sides, and that's where that 5.4 comes from. And then divide by 0.9, and you end up with x equals 6. And again, x is the amount of the pure. So if this was 6 kilograms, 36 minus 6 would give you 30 kilograms. So technically there's two answers, 6 of the pure and 30 of the 10% stuff. Number 51 is next. 30-liter solution, this is an amount, is 50% antifreeze. How many liters of antifreeze, remember antifreeze is 100% stuff, must be added to produce a solution that's 70% antifreeze? Remember, if I say 100%, that means it's pure stuff, but like for example, you might see in the final that it might say how many liters of water, which hopefully you know has 0% antifreeze. Well, in this case, I'm adding antifreeze, which is 100% antifreeze. So, let's show. Okay, so for number 51, kind of sloppy, I'm sorry. Trying to get this done in a short amount of time. So, you have the 50% antifreeze. They tell you there's 30 liters here. The pure, which is the 100% stuff, is the amount we want to know. Let me show you what I'm talking about. We want to know how many liters of antifreeze must be added. So how many liters means that's the x. 30 liters of the 50% stuff, x of the 100% stuff, to produce 70% antifreeze. Okay? So this column right here, 30 liters of the 50% stuff, I don't know the amount here. And when you mix them together, when you are given one of the two, you add them. This just comes from the percents, 50%, 100%, 70%. Multiply those, you get this. Multiply that, you get that. Distribute that, you get this. And then the equation comes out to be 15 plus 1.00x is just x equals 21, which is that times that, plus 0.70x. Now you have variables on both sides. So if I show this step, if I subtract, and I'll make this 1.00, if I subtract 0.70x from both sides, I end up with 15 plus 0.30x equals 21. Then I subtract 15 from both sides, and you end up with this. 0.30x equals 6, 21 minus 15. And then you divide by 0.30, and that gives you x is equal to 20. And they're asking you for how many liters of pure. Since x represents the amount of liters of pure, your answer is 20 liters. Okay, last one, 52. It's the coin problems. How many quarters and dimes are we looking for? So Mary had 7 more than 2 times as many quarters as dimes. Mary had 7 more than 2 times as many quarters as dimes. Well, that means that dimes is going to be the unknown value. So let me go ahead and show you the paper here. You know a quarter's worth 25 cents, a dime's worth 10 cents, and you know the total value is $10.15. So let's take a look what this looks like. Okay, dimes and quarters. Dimes is the unknown. And here comes fifth period. The question says there are 7 more than 2 times as many quarters as dimes. 7 more than 2 times means 7 more than 2 times. Dimes are 10 cents, quarters are 25. That times that is that. 25 cents distributed to this is going to be what this comes out to be. And now they're saying, well, this amount of dimes and this amount of quarters gives us a total of $10.15. Now this is just simple solving the equation. You're distributing, you're combining like terms here. But essentially, setting up the chart is the hard part, and then just not getting lost in the work. So you combine like terms, you subtract all this stuff, and you get down and you end up with x equals 14 dimes. Well, that's only half the answer. How do you get the number of quarters? If this is 14, 2 times 14 plus 7 is 35. So I'll leave this up here. You guys can slow this down, press pause, go back. Hopefully this will help you with your word problem review. Sorry about the sloppiness. I wanted to get it done before you took your test, obviously. Good luck.